why I created TestDriven JS and why I'm offering this course for Pluralsight, because there's not enough test-driven development going on when people are doing their JavaScript. Douglas Crockford said that JavaScript is the only language where people feel like they can program in it without bothering to learn it. And I'm sure for those of you who don't do JavaScript primarily, you find that you write a lot of 40 and 60 line functions, and tests just don't even seem to fall into the category, let alone test-driven development of what you would spend your time on. So my goal for this course is for those of you who are using JavaScript and not doing test-driven development with your JavaScript, you'll feel comfortable going back and doing not just unit testing, but actually doing test-driven development with your JavaScript, regardless of the size of the JavaScript. For those of you who are doing JavaScript a lot and working with large, big frameworks, you're going to have to extrapolate some of the things that we talk about today to how this would work on much bigger frameworks, because what we're going to go over is going to be a very, very small piece of code, you know, like Uncle Bob's bowling game kata. It's just a small piece, and it's a great way to showcase some of the things, but to do it in a large application of JavaScript is definitely going to require more thought than just applying exactly the principles and the techniques that we'll talk about here today. But it should still be very useful for you. So my first question is and also I want this to be very interactive, so please don't hold your questions to the end. Raise your hands as soon as you have your question. If I'm going to cover that question later, I'll put you off, but please raise your hands as soon as you have questions. We will definitely be pausing to discuss questions and go over everything. I want everybody to have a good idea. If you happen to have your laptop and have internet connectivity and you would like to follow along with the code rather than just watching, jump out and download Qunit and a copy of jQuery, or just grab the link to jQuery. You will need Qunit if you want to follow along, and we'll start up coding in about 10-15 minutes. So, here's a question for everybody. What is TDD? That's a good definition of TDD.
You write your tests before you write your code?
Write your tests before you write your code, okay. That's a great example. Or that's a great answer, excuse me. Great answer. What is the little mantra of TDD? 3 words, has 2 or more colors. Who knows what that is?
Red, green, refactor.
Red, green, refactor. So when we TDD, what does red, green, refactor mean?
You write the test, expect it to fail, then write the code and expect your test to pass, and then refactor.
Okay. So if you write a test and it passes, is that a little bit of a smell? It is. It'll happen, and we might actually have this happen today, but it is a bit of a smell. You want your tests to be failing, and then you want them to pass. Now, in the red, green, refactor cycle, how long do we want how many tests do we want to be read? Just one. Just one we've most recently written. How long do we want that test to be read for?
5 minutes.
5 minutes? Okay. Anybody else have an answer? My preferred answer is as little time as possible. Okay? We're going to do what's the quickest, least amount of effort to get that test to be green. And then we spend most of our time in the refactor phase. Sometimes we spend most of our time in the refactor phase based on the project. But we want, as soon as we have a red test, we want to make it green. We want our test to be green as soon as possible. So to do that, we want to take small steps. Okay? Who here has read anything or had a discussion about one assert per test, or knows what that even means? A couple people? Okay. One assert per test is definitely debated heavily. In test-driven development, one assert per test is usually a good thing, because what that means is that your test is trying to get a very small piece of functionality to be added to the project, right? So we don't add 10 asserts, we don't add 20 asserts, we add 1. Now, I will say that the debate about whether or not it's actually one assert line, I think is kind of silly. One logical assert. For example, if you're testing that a collection that you've created has the item that you want in it, you might need to test both the size and the contents of the item. That might take 2 or 3 or 4 asserts, but one logical assert per test, right? We want to have more tests, okay? Get to green as quickly as possible. All right. Now, why should we do test-driven development? And specifically, why should we do it in JavaScript? So here, the first question is, why should we do test-driven development at all?
Quality.
Quality, okay? else have any answers?
Keep your job.
Keep your job, okay?
If your tests are being written properly, then it helps to ensure that the code that you're writing actually has the behavior that you're trying to codify.
Okay, excellent answer, excellent answer.
I would say sanity.
Sanity?
Yeah, so you can make changes and know you didn't ruin everything.
Okay.
It helps flush out requirements you may have missed.
Excellent, all excellent answers. The first answer that came up is my favorite answer, and what I believe is the #1 reason why we should do test-driven development is because we do not want our workspaces to look like this. Not our physical workspaces, but our virtual workspaces. The input to the work that we do today, the primary input to that, is the code that we wrote yesterday. So the determining factor on how productive we are today is what we did yesterday. So what we want is for test-driven development to help us to create code that is organized, that is maintainable, that is quality, that is clean. So our #1 goal or benefit of test-driven development is to write better code. #2 is to actually create the unit tests, which can be counterintuitive for those that are new to TDD. But the benefits of having unit tests are many and varied, but the best benefit by far of having TDD is the fact that we're going to write better code. So benefits for TDD are we can safely refactor our code, right? We know that the application still works as we make changes. We can make enhancements to our code and be confident that those enhancements aren't going to break existing functionality. Kent Beck's book on TDD, which if you haven't read, I recommend you read it, has a great example of how they had this currency and they needed to know if the currency class would support international currencies. So it took them like half a day, but all their tests were passing, and so they felt confident to say that, yeah, we can make this work. Documentation of requirements and behavior. Our tests help us know what our code is actually going to be doing. We can read through the tests and know how code behaves. And lastly, reduction of bugs. So test-driven development unit tests help us flesh out and get rid of the bugs. But again, bug-free code is not necessarily the best benefit of test-driven development. I like to ask a rhetorical question, that is, would you rather write quality maintainable code or bug-free code? Alright, it's a good thing to think about. Alright, so client-side versus server-side TDD. If you haven't done any client-side TDD, the big difference by far is just a lack of maturity in the tooling. There is a lot less man-hours that have gone into client-side test-driven unit testing frameworks, and of those, a lot, even a smaller percentage of that is test-first development, test-driven development. So you can run into quite a few hiccups when doing TDD. All the same facilities are there, but one of my biggest pain points is frequently a client-side library doesn't point out to me the problem in my code as easily as a server-side testing framework does. All right, so there are a lot of JavaScript unit testing frameworks that are out there. 3 of the most popular ones out there are Jasmine, Qunit, and JS TestDriver. We are going to use Qunit in our demo today, but there are a lot of frameworks out there, and they'll have things that are slightly different from one from another, especially when it comes into hooking up with your CI system. But by and large, they all work fundamentally the same. So anything we do today in Qunit, we can do in Jasmine, we can do in JS TestDriver, we can do in tree.js, which just came out, anything. All right, so let's talk about setting up Qunit. So I'm just going to go over this briefly because this course is not about how to set up Qunit. So if we want to set up Qunit, the first thing we ought to do is get the source code. You just go out to this URL or you just Google Qunit and download it. It's a zip file and it's got a lot of stuff in it, some add-ons, some themes for look and feel. By far the most important, the 2 most important files in there is the Qunit.js file itself and Qunit.css file to style the output of your tests in the web. And then the other file that usually is a good idea to grab is their test HTML file. And I'll show you that in a second. And you can use that just as a template for creating your own. Once you've downloaded the source code, then you want to create your test runner file. So let's take a look at what that looks like. This is an example test runner file. There's a few important points here to note. These script tags are kind of the key on what changes in your test runner file. The rest of this is just all boilerplate HTML. So any third-party libraries that you're going to need within your tests, then Qunit itself. Then here we have our system under test. This is the actual code that we're trying to build, right? And then after that is our test files. Now, we can include more than one test JavaScript file here. We could have 5 test JavaScript files here. And there definitely is going to be questions about how many HTML files should I have versus how many JS test files do I have. And there's not necessarily a right or a wrong answer to that. Kind of depends on, as you're writing code, what you feel like gives you the best organization. But when you open up this, when we open up this HTML file in the browser, it's going to run every test that we've referenced within that. So the good thing is, about including all of our tests in one HTML file is we can run all of our tests at the same time. The bad thing is it's a little bit harder to drill down and just run subsets of tests. So there are other projects out there. In fact, the download for Qunit has one called Qunit Composite that allows you to take a whole bunch of these HTML files and piece them together. I won't show that, but get a feel for exactly what I mean by running these HTML files during your tests. So the organization there, again, does matter, but it's something that there's not necessarily a right or wrong answer, and you'll kind of figure it out as you're building stuff. Okay, after you created your test runner file, then we actually want to create our test file, which again is this tests.js file, and this doesn't even need any real boilerplate. Okay, this is going to be an empty JavaScript file, and we can just start coding our tests right into it. And then, as soon as we got that done, we can start writing our tests. So let's go into actually organizing, let's see. I want to discuss very briefly organizing your test code. If you are testing a lot of JavaScript files, so you got 10 or 20 JavaScript files in a project, you're going to test all the content of all 10 of them. It is a really good idea, one, to keep your tests separate from the system under test. Okay? Don't put your tests right alongside. This is the same principle in server-side frameworks. You don't want to be having to worry about pulling them out when you're trying to deploy or build to your production server. You want to keep those into separate locations. Okay? It's a good idea to mimic the structure of your system under test. So if you have 10 different files and they're in 6 different directories, create test.js files that are in a structure that looks just like that follows the same pattern, right? So if you have 5 JavaScript files in your root folder, and there's a subfolder that has 5 more. And when you're creating your test files, create 5 test.js files in the root and 5 in the subfolder that just basically are the same name with the suffix of tests. That's my preferred way. You can come up with your own kind of way, but again, organization is going to be important. Don't start off with just coding your tests like right alongside and then end up in a big swamp of a mess you have to clean out. And then again, I discussed this very briefly, how many test runner files, HTML files do you need? So looking at this HTML file, we have just one test. So if I had 10 JavaScript files, I'd have the choice to either include 10 of them or create 10 of these HTML files and run them all separately. And that really is, again, personal preference. And using Qunit Composite, you can combine all those when you want to run all of them at the same time. All right, so we are going to start TDDing a real app. Okay. So what I want to do for our demo today is I want to test drive an actual application that is a to-do application, inspired by Adi Asmani's to-do MVC project. I want to for us to create a little tiny application that just gives us a list of to-do items, a little button and a text box to add new items, maybe a little delete icon next to each one. At the top, we'll display how many tests or how many to-do items there actually exist in our list. Okay, so that's kind of the basic requirements. Is anybody confused? Anybody have any questions about what our requirements are for our project today? It's important to understand we want to put a number up at the top, we want to display each item, we want to be able to delete them, add them for the user. Okay? Alright. So, for those of you who actually do TestDriven development, so I'm throwing a little bit of boilerplate here, just because I wanted to show one. I don't want this to be about the JavaScript. So for those of you who have questions about JavaScript, about any of the techniques that I'm using here, that's kind of not the point of what we're doing here. So those kinds of questions, if possible, hold them to the end. I'm just using some good template boilerplate here for doing my JavaScript. For my to-do app itself, I've created again some boilerplate using the prototype pattern to create the actual application, because I know that I'm going to need a to-do list. Although I would typically test drive actually even that much. My first test would drive the need for this class, and so this would actually be empty, but I wanted to have the boilerplate up so we could get right in. If we're going to write our Qunit tests, we want to start writing our tests. This is it. It's very simple. We just call the test function. The first parameter is a string, which is the name of our test. And then we pass in a function as the second parameter that actually runs the test. Qunit requires you have at least one assert. So those server-side frameworks that let you just exercise the code without asserting anything, thankfully Qunit doesn't let you do that. It will throw an error if you try to do that. So its asserts are a little funny. The server-side frameworks that I'm used to that have like an assert dot or an assert with a suffix that actually like assert equals, they don't use that convention. I'm not really sure why. That was one of the things I didn't like about Qunit. Qunit was, by the way, was created by the jQuery team to test jQuery. So that's where Qunit came from. So there basically is true, assert true test, that's just okay. We're going to pretty much mostly use the equals, so it's strict equal. There is an equal assert. For those of you who know a little bit of JavaScript, the difference between the double equals and the triple equals, strict is a triple equals, meaning that the string 1 is not the same as the number 1 when you use the triple equals. And that's, by and large in your test, you want to have that kind of comparison. You don't want your output to potentially have been a string when you really were expecting a number. You compare it to a number, it passes, and everything's hunky-dory. You want to, by default, be using strict equal. There's some other ones. There's a deep equal where it actually will look at objects and see are all the numbers the same. And there's not versions of all of these. If you have any questions about the Qunit site, there's only about 10 different asserts. It's very simple to look into and see. So strict equal, of course, is going to take 2 parameters. And then what was different for me, again, versus server-side frameworks was the expected value was the last parameter, not the first parameter, and the actual value was the first. I was used to the opposite way. And all of the asserts have an optional parameter at the end, which is a description of the failure. This failed because, of course, you can't use single quotes in the middle of a single quote string. I don't typically use them. I find that they can get out of date, but there's no reason not to use them. But that's in all the asserts. They have an optional final last parameter. Okay. So let's start building our to-do application. Okay. So we know that we need a list. It's got to keep track of all the items that we want, and we want it to be able to display on the browser each of these items. So for those of you who have done some TDD, what should be our first test? If you're going to write this server side, what would be your first test that you would write?
That the list is empty.
Okay, the list is empty. All right. So new lists are empty. Now let's new list is empty. Okay. So we created our new list here. So I want to know if it's empty. Let's say dot get size method, and then we're going to compare that to 0. We want that to be empty. Okay. We've written our first test. Now we want to actually see if this works. So go to not that browser, this one. Test and run it. Okay. Object has no method get size. So again, if you are used to server-side frameworks, you'll see that this error message is slightly less helpful than one you might be used to on the server side, but it does at least point out that, hey, we have no method get size. Okay, easy to solve that problem. What code should we write here to make this test pass? What?
Get size return 0.
Okay. Now I'm going to be a little Nazi about this. I'm not even going to return 0. All I'm going to do is make the error that I'm getting pass. How do I set that? Okay. Now I'm getting a different failure. It's expecting a 0, but it actually got an undefined. So we'll do that said return 0. Boom, our test is passing. Okay. We got that working. What's our next test? What would we want to know next? What our list can do?
That we can add an item and it actually shows up.
Okay. I'm a big fan of the give them and then syntax, so once my tests get beyond the really, really simple, I tend to go towards that. Given an empty list, adding an item, and an item, and the size is 1. And I don't like the phrase that, and an item is added. So one of the things that I do really like about JavaScript testing is the fact that my unit tests can be sentences with spaces, no more underscores to try to make words appear in camel casing to make it try to look like actual words. I can just pass in a whole sentence that can be as long as I want. Okay, so we got this to-do list add, and then let's put in a string. Alright, and then once we've done that, then the size should be 1. Okay, the test should be correct. Over here, we run it. A failure object has no method add. Right back into our code, we need an add method. Okay, so following the pattern we did before, we're going to just add the add method. And run it.
Just do function.
Ah, I'm very good at messing that up. Okay, expected 1, result 0. Alright? Okay, how are we going to make this test pass? This is, I actually have to use more than just 2 brain cells. How are we going to make this test pass? Return 1. Okay. If we return 1, though, what happens to our other test? It fails. So we can't break the other test to make this test pass. Or we're going to make both tests pass.
We need a collection to store stuff in.
Okay.
Or a Boolean.
One item. Alright, so we could just put in a Boolean that just says, hey, if they call to add now, we're just start returning 1. That sounds actually like a fair amount of work. You're talking about adding a list, but that's actually more work than I absolutely need to do.
What about just a number?
Yeah, what about just a number? Alright, let's create a number. We'll initialize it as 0. We'll return it here. And then here we'll increment it. Okay? Let's try that. Alright, our test is passing. Awesome. Okay? Just as a sidebar, who here has done TestDriven Development this kind of baby steps? Who does this? Cool. I kind of like this sort of method. I watched Uncle Bob do some pretty cool stuff following this method. Being very, very, very strict about your TUD. Okay, so now this is passing. Let's write our next test. What is our next test going to give us? What feature are we going to add?
Check that the text of the item is that text we had.
Okay. If I want to check the text of the item, what do I have to do in order to know what the text of the item is?
Sign it.
What's that?
You have to sign it like a title or something.
Okay. I have to sign it. You said like a title?
Yeah.
Okay, so I'm passing in just a string right here. If I want to test that the text is correct, I know that I've got to be able to ask. This is kind of what I'm getting at, is I've got to be able to ask that collection, give me an item at this index, right? Do I know that I need that method, that function? Do I know that this class needs that function?
Not necessarily.
Not necessarily. Remember we said at the beginning, I need to be able to display at the top of the list the count, right? So we know we need to be able to ask for the size. So there's two purposes for the get size. One, it helps us test drive some functionality into our class. But two, we know that we need the ability to ask the class, hey, how big are you? How many items are you holding? We know that the UI is going to require that. Now the UI needs us to display items, but it doesn't necessarily, we don't know exactly how we're going to ask our to-do list to display items. So this is one of the beautiful things about JavaScript, and we're going to do, what we're about to do is we're going to start test driving our DOM, okay? This is one of the things you can do in JavaScript that you really can't do in any other language framework that I'm aware of, and that is test driving the view, okay? And pretty much every other technology, anytime you want to test the view, you got to use something like weird, like for web, you got Selenium, something odd to kind of parse what the output is, but you really don't have the opportunity to test drive with unit tests. Whether or not that's a good idea is an entirely different question, and that kind of really depends on what you're building, how big it is, and what frameworks you're using. Now, if we're going to write a really big project, we're probably going to use something like an MVC framework, okay? In an MVC framework, whatever the classes are that handle the views probably have their own method and functionality for how they work. So in that case, our test-driven development is going to drive us to build the views to do this sort of stuff. We're not using an MVC framework for simplicity, so we're going to we want our classes to actually operate on the DOM directly themselves. But what we do not want is to mix responsibilities. Okay? So even though we're not using an MVC framework, we don't want our one class to have the responsibilities both of keeping track of the items and displaying them, handling DOM events, that sort of stuff, responding to the view. We still want to split those two responsibilities. So what I want to do, and before I go on to that, I just noticed something, a little error that we made. What do you see here? I got this, here, I got that, and I got that. I got duplication in my tests. I don't need duplication in my tests. In a server-side framework, we would have what to remove duplication in our tests? Yeah, and try to set up something like that. Can we have that same feature in client-side frameworks in Qunit? It's called a module. You just call the module function. I'm just going to call this the list tests. And then instead of a function, you actually pass in an object as the first parameter, or as the second parameter, and the object itself has two members: setup, which is a function, and tear down. Now, both of these are optional, they're not required. I could just put the module in there by itself without that second parameter. And what that does to my tests when I run them is it prefixes them with the name of the module. Qunit itself has a couple little features for running tests. If you just hit the web page, that your test runner HTML, it runs all your tests. You can see over here, it's kind of hard to see on the monitor. Once I hover over it, there's a little rerun. If I click that, it'll only run the one test. Now, you'll see that it's running two tests. The problem is these two tests are named the same. You can see the way that this works is it just creates a little filter up there, and there's just a big long string description, string parameter for that filter, and anything that passes that, and basically contains in, is how that works, will get run. So if I just put in list, the word list here, I can run all my tests that have the word list in it. So if I put in list, tests, like that, now I'm kind of running that module by itself. Unfortunately, there's no quick link. If I click on one of these tests, it actually expands and shows me all the asserts. There's no real way to just run all the tests in a module other than manually creating that URL parameter. If I click just one of them, again, it changes the URL parameter to that. Or if I have no URL parameter, then it just runs all the tests that I've got. Okay? So that's what a module is and what a module does. So let's move our common code out and put it in the module. Alright. We'll run our test again just to make sure that things are still passing. Okay, things are passing. Alright.
Are those run per test or per file?
Setup is run per test. It'll run on every test, so we'll tear it out. Alright, so we want to start building the view. So I'm going to create a new module, view tests. And I don't know yet if I actually need anything, so I'm just going to leave that blank. So we said that our next test is we want to know that the text is correct, right? Well, the real test is, did the text that showed up in the DOM, was that the same text that I added to my collection, right? So that's what I want. That's what the test I'm going to write is given an empty list, and adding when an item is added, and except now I'm testing my view. What I don't have is a test that says, hey, do you have the right number of items that are actually showing up based on what you're adding? So I think I'm going to reconsider. Instead of checking the text again, I want to test that the view is going to put up the right number of to-do items on the list, right? So let's change this test. We're going to put a pin on checking the text, and we're going to make this test be then the number of to-do items is 1. But, okay, I'm stepping ahead of myself again, right? I'm testing the view. I don't know that, begin with the view, does it start with an empty list? Does it start with an empty list, does it start with 0 items? So let's back up. I'm going to put in that test, give it an empty list. Then the number of to-do items is 0. And let's call it, instead of to-do items, call it to-do nodes. 0. Okay. Standard misspelling. Alright. Now, we are going to start test driving our DOM, and it's worth discussing at this point the fact that DOM, one of the reasons that it's recommended not to do a lot of testing of your view is because view tests are brittle, especially with things like Selenium. View tests can be very brittle. This is still true even with a unit test of JavaScript, that your DOM can be brittle. So let's look for an example of how I think we might end up crafting the HTML that is going to be displayed when we have our to-do list. Okay? So I've got this div, and I'm not sure where I'm going to put my delete button. So this div represents one item, right? Not sure where I'm going to put my delete button. I'm going to put my text in here, my input button, and then I might have some more, you know, like maybe some context menus, maybe some for context menus that might pop up. Maybe some more HTML that's going to help me style the item correctly. Now, for the moment, ignore these class names. But I'm not really sure how this HTML is going to be crafted more. And further to that, if I do write tests that assume that this HTML looks exactly the same way, as soon as we decide to refactor the HTML at all, the view at all, and change the look and feel, I got tests that are breaking even though the functionality is still working. If I change this div to an article, or if I change the span to a div, based on how I lay out my CSS, the view is still going to be correct. But if I make a test that relies on saying, hey, I'm going to have a div, and within that div I'm going to have a span, and that's within that span, you know, the first span is going to have some text in a certain way, I'm going to have a very brittle test. So, when we're writing tests that test the view, what we want to do is make our tests as non-brittle as possible. So, my preferred way is to write classes around the objects that I care about, make them as granular as possible, and prefix those classes with JS. I like JS dash. Some kind of a prefix you're just not going to find for your CSS classes. That helps you when you're looking at your HTML understand that this class, you know, we might have 5 more classes on here that have to do with CSS, right? Maybe we're using object-oriented CSS, so we're going to have 5 or 8 classes styling that up. We know that this particular class has nothing to do with display. This has to do with our functionality. Okay, so that's what I like the prefix. By no means is it required. So if we put these classes on here, now my test to say, hey, is the number of nodes 0? I can just ask, all right, there's got to be a container, right? Theoretically, I could do this without some kind of putting everything in a container, but probably be a pretty bad idea. So I have some kind of container. Within that container, just look for how many items have the JS-to-do item class, right? If I count those up, no matter how I change my HTML, no matter how I lay that out, this test is still going to pass. So I'm going to make this test as non-brittle as possible. Again, how much you test drive your DOM, and how many unit tests you write for your DOM, and how wise it is to write unit tests for your DOM is not necessarily obvious, right? Writing unit tests for the DOM in a simple case like this seems like it's a really good idea. As things get bigger, as you start using MVC frameworks, that may not necessarily be the best thing to do. You might back off of writing so many DOM tests because you find that it just gets really brittle. If I don't think we'll have time, but if we go all the way through implementing delete functionality and the add button functionality and listening to those events, we actually end up writing a lot of code that in our tests are doing a lot of stuff that makes our tests a little bit harder to read and a lot more setup. Things I prefer not to do if I don't have to. So, but for something that's simple, it's easy to test drive the DOM, and for bigger projects, it can be easy to test drive just based on the environment and the frameworks, the third-party libraries you're using. So, if I want to count up, that's the reason I included jQuery, I'm going to have to have some kind of container, right? So, let's say var container equals, let's grab list container. Alright, and then let's say container find, and then it was JS dash, was it list item? To-do item, alright. Alright, now I can grab the length of that, compare it, it should be 0. Alright, now I don't have my list, so I can put in my list in here. Because remember we're in a different module, right? So put that in there. I'm not putting it up in the module yet because I don't know if this is duplicated code. Alright. Let's go run that in the browser and see what we got. Hey, our test is passing. So here's a great example of we wrote a test. It was green to begin with, it wasn't red. This is just a functionality of jQuery and how jQuery works. Just the fact that jQuery doesn't really care if you ask it for something and there's nothing there, and then you ask it for children, it still will return, hey, this thing that doesn't exist has 0 children. So our test is passing. But we write our next logical test, which would be what? Would be our next likely test.
Add an item, there's one.
Add an item, there's one. Right, this one is going to fail. Alright, it's expecting 1, it results with 0. So in order to make this pass, well, we talked before about the fact that we don't want this to-do list to have the dual responsibilities of maintaining the model and the view. So I don't like the fact that I'm going to have to, the only logical place for me to put that code is into that to-do list. I want this to-do list to be my model. So I want a new view item. So var to-do view is named to-do. Okay. You spell new correctly, and then I'm going to pass that the to-do list. Okay. Now, I might want to decide, does it automatically render the HTML as soon as it's initialized, or do I need to call a render method? Let's just assume for now it's automatically rendering as soon as we initialize this class. So, because I just don't have a strong preference one way or the other. Let's duplicate this. This is to view. Actually, I should have made a mistake there. I should have run the test before I added that to-do view. I finished writing my test. I should have run that test and got a different error and then fixed it. I didn't, so that was a mistake. But let's assume we did that. We did correctly. We ran it. We got an error that says there's no to-do view. We created. Now we get the error that hey, we're expecting 1, there is 0. So let's make our to-do view actually create the information. So I'm going to need, in my args, I'm going to need the container. And I'm assuming that's going to be a jQuery object, so I'm just going to do .append div with a class of, what was it again? JS-2 item. I think that's the minimum amount of code. Oh, can I call with append? I'm gonna find. Okay, so I wrote some code in my class that I'm not handling in the test, right? This is expecting a container. I'm actually passing out a to-do list. Let's go back to using the options, and then we'll do a container, which will be our container, and a container. Okay. All right. Expected 1. Result was 0. So now JS dash. Now I don't know why that's failing. So here we get to do actually some real debugging. My init should be getting called. I'm giving it a div with a class of JS2 item, container dot. I make this mistake very frequently. Oh no, that's no mistake. That was correct. I actually made the mistake the opposite way and put in the class and put in that dot. So that's not incorrect. So let's go back to our browser. We're going to open up our tools. We're going to go into our to-do.js. We're going to go down to the view, set a breakpoint there, and we're going to run just that one test. Okay. So args.container is the HTML list container that I expected. If I add the item, let's look at expression on args container. Seems to be okay, so let's look at the HTML. Okay, so guess what I forgot to do? In my setup, I forgot to actually create this, where are my tests? Okay. I'm grabbing this, but that thing doesn't exist on my page, right? Okay. So let's go back to the module and let's create a setup method. And let's add that thing. So, body, append, equals list container. Close it out. All right. Now that I'm adding it, I want to clean up after myself. So here's a great example of why we need a Jedi function. Thing. Alright, now let's try our test again. Breakpoint. Okay. View tests, green. Alright. So we do have 2 of the same test. Name. This is supposed to be is 1. My test wrong. Them all my tests are passing. Oh, there we go. Rerun just this one. Okay, all my tests are passing. I'm green. Okay, so now I know that I've got a view object. It is adding an item. What's my next test?
That has the right text.
Has the right text in it. Okay, fantastic. Let's just duplicate all this. And that. Alright. Now I want to look for some duplication here in these tests. Lo and behold, I've got grabbing the container, so there's no reason to do that in all those places. I don't want to set it there because it doesn't here. Put some unnecessary white space I've got. Over here. What else have I got? The to-do list is also duplicated. Alright, okay. Now, it looks like this view as well, and the to-do list.add is duplicated, but I'm probably going to be writing some tests that add varying numbers of lists, and since it's a parameter into my to-do view, well, it's not a parameter yet, but I can make a pretty safe assumption it's going to be a parameter. This is not good code to refactor out and get rid of, so I'm not going to remove that. So, our new test was doing an empty list when an item is added, and the text is correct. Alright. Okay. So, we got our to-do list, we add an item to it, call the to-do view, we want to check the text. So, again, looking at my HTML example, we've got a container, some kind of container that has the class to-do item. Somewhere within there, I'm going to have my text. Now, if I want to write some more brittle HTML, I would just throw that text right inside the div. And my test for right now would work because I'm creating this containing div that has some text inside of it. But again, thinking towards the future, if I change the HTML around, I could have lots of other text that's in there, and also my tests are going to start breaking when I change the actual HTML that gets rendered. And naturally, in a project like this, you'd probably be using some kind of a templating system. So you go and you change your template, you have no idea that you did anything to do with your tests start breaking, right? We don't want to do that. So here's a great example of a way to do that. I want a container that is only going to contain my text, that has a class that I know to look for, and then I'll just look for that item within it and grab that and then check the text. So in order to do that, I want to do find JS what was it? Item text, and then I want to get text, and then I'm going to test that it is the new item. Okay. All right. I'm failing my test. How can I make that test pass? What's the minimum amount of code I need to write to make that test green?
Test on the page.
What's that?
Put the message on the page.
Message on the page, like, okay, so here we are already inserting the div. Let's just insert a static span. And it could be anything again. JS-item text. And then what was it? New space item, right? Okay. Run it. Test is passing. Okay. Now, if you are a Kent Beck follower, what you'll do at this point is go back to your tests, your code, and say, look, I'm putting in some hard-coded stuff. Yes, I made it pass. It's kind of dumb. I'm going to refactor and actually make this dynamic. If you're more of a Uncle Bob kind of follower, you'll write another test to force you to make that code be dynamic. I'm a little bit more of an Uncle Bob follower, so I want a test that's going to force me to make that be dynamic. So I'm going to do, what tests could we write that would force us to have to make this no longer be static text?
A random value in there?
Random value? Okay, that's one option. We could just, well, if we just had two tests with two different inputs, that would. But let's give us a little bit more functionality while we're at it. How about we add two items and we'll check that the last one has, with different text, we'll check that the last one has the text that we want, right? So we're looking for new items, space 2, but this time, when we do a find on the JS2do items, if we just do an initial find again, we're just going to get the first one. So I want to do .last, and then within that, I'm going to find the item text, and then grab the text, okay? So new item 2, back, run, failing. Expected new item 2, but it found new item. Okay. How am I going to make this code pass? append another one. Okay, that is going to make it pass. This is definitely that point where you say, you know, how harsh am I on myself, on my tests, right? How much work is it to append another item? I mean, in this case, it's Control D, but the line of code and what's going in there is starting to look like really poor code. It's very duplicated looking code. So if I did do that, that gives us a much easier way to say, you know what, now I've got duplication within my class, right? I've got this duplicated code, I can do some refactoring, and that might drive me to something, but for me at least, I've reached the point where, okay, I'm now doing kind of silly things. So, which is kind of a funny line, right? Here I am hard coding in these things, and all of a sudden this is silly. Right? We each have our own lines, right? So I'm not going to do that. What I'm going to do is, I know that I'm going to get in here I need to get some kind of a thing. Let's just call it the item. And I'm going to put it right inside my string. Again, you should be using a templating engine for this. I'm just doing this hard-coded HTML, which is a really bad idea for simplicity. Okay. I need the item. Well, I know that the args is coming through, and the args is going to have that to-do list in it, right? So, well, it doesn't yet, but I want the args to have that. I could certainly put the to-do list into the args. So, let's say args.to-do list. And now I need to what? If I have access to the to-do list, what do I have to ask that to-do list? The to-do list has the actual items of the text, right? Why do I need to be able to ask it? Loop through the list, right? Yeah, I need to be able to get the items out, right? So there's a lot of ways I could do that. I could just ask it to give me the list back as an array. So I can call like get list as array, or get list and assume it's an array. I could do a for loop. I've already got a get size, so for loop kind of is nice because I know I can already loop through the number of items. So let's go with that method. So then get size plus. Okay, now this item, what do I need this to be? I need to be able to ask the list for an item in a certain index, right? Item at like that. Sorry? Oh, args.to-do list. Right. Okay. Now, this code. Okay. There's no method item at. I'm just now broken 3 tests. So rather than fixing the other tests, I'm just going to focus on the one that I didn't name. And clean up this one too. Items. Added. Text. Last item is correct. Okay. I want to fix just this one test. So let's see here. I'm going to view. There's no the error is there's no item at. So now I have actually a choice to make, right? I can either go and test drive the item at into my list first, and then assume that once that test is passing, this is passing, but I have a red test. So if we are going to be purists, we want to do it that way and go back up to our model and write tests to drive the functionality of that method. Then we would comment out the failing test. But we got several tests that are failing. Our other option is to just make this test pass, and whatever we have to do to the sub-object to make it pass, then it passes, and then we go back. If we need to write more tests around that, we can. We may not need to. Let's try that approach and see how that works for us. Okay? So I'm going to go up to my to-do list, and I need an item at. All right. Index. So I'm on a list. All right. So now at this point, I'm going to have to change quite a bit of code to get my list in there. I'm still back. I stop myself and I think, do I want to comment out my other tests and go back and test drive in that this works? I would say I would probably do that in a typical situation. In this situation, we actually have so little code to get that list in there. In a real project, you know, one line of code per method is nice, and you're going to see that certainly a bit of times, but we all know that that's usually the exception more than the rule. We have a few more lines of code, so we want to add something pretty significant to our class, like a whole list. We're actually going to have to write a fair amount of code. And so at that point, I'm thinking, I might want to actually write tests around this, get that to pass, and then go back to my view and get that passing again, right? But that is definitely a dangerous thing to take, because I start writing tests assuming what this view needs, and I start writing too much code that I don't need. I start writing functionality that I'm not going to need. I didn't even know that I needed to access an item at a given index until the view required it. So if I start writing tests around the item at, I might start throwing in a whole bunch more functions, writing in a whole bunch more API, thinking, hey, it'll be really convenient if I can get this list in reverse sort order with, you know, everything appended together with commas, whatever. I don't want to do that, so I want to always resist that temptation if I'm going to, if I know I have functionality driven by another class, but I'm going to drive it into this class by tests just on this class, always be careful to only drive in the functionality that I actually need. For brevity's sake, at this point, I would just go in and add in the list, and you know, I can create a this.list, and make it an array, and then, oops, what do I do? And then go in and I might remove size. I could always I can comment out my tests and run the other tests, make sure that I'm not breaking anything as I'm writing this code. So, you know, it's not really simple and straightforward, is it? But it is interesting.
You can just throw this question away if you want. And I realize we did this for the sake of showing how we go through the process, but if we take that same train of thought, it seems to me like we could have just said, there's no reason for us to create a to-do list object at all, right? I mean, we could have gotten to the point where we say, well, every time we say, well, I want to see if I create one, it's size 0. Well, my array can already do that, and so on and so forth. So we might get to a point where really all we're doing is just writing unit tests for the view, isn't that?
That's
true?
Absolutely true. The biggest reason that we're dealing with two classes, and I gave this presentation before, and we actually did it in just one class. And a lot of people point out the fact that, hey, you've got a model and a view really here in one class, right? And as your class grows, those two responsibilities are going to conflict over each other. I can write this code, it'll be correct, it'll be passing, and those two responsibilities mixed inside of one class. As that grows, it's going to make this class hurt more and more as I have to maintain this class. So, you know, it's very proactive at a class this small to separate it out into two responsibilities. It's a hard decision to make. Wow, I got this little tiny class and it kind of has two responsibilities. Should I separate it out or should I keep it together? I know that if we created this as a full-fledged thing, we're going to want this. We're going to want separate responsibilities out. I'm thinking ahead. One of the things that TDD kind of tells you not to, don't think ahead, right? But I still know that the single responsibilities principle says only have one responsibility within each class. Manipulating the view and maintaining the state of the model are two separate responsibilities. So it's not necessarily that keeping that all within one class wouldn't work, or is even entirely wrong, but if I want to follow the principles of TDD and follow all the other solid principles, single responsibility says make this two classes and keep the view's responsibilities separate from the model's responsibilities, so that's why I would separate this out. Kind of hokey in a little tiny project like this to have those two little classes, but for demonstration's sake, what I don't want is for people to look at this and say, hey, in the 40 lines of JavaScript that I'm going to write, I'm going to just do it all in one class and do everything whatever it matters, and then as that grows into 300 lines of JavaScript, I've got a big ball of mud. So be thinking about those sorts of things as you're doing your test-driven code. There's a great quote that I read is that test-driven development is like a series of blind turns in an alley. And that absolutely can be true if you don't do, you know, kind of a Jedi thing. Just enough design up front. Stop, pick your head up and look ahead and think, you know, do I have multiple responsibilities going on? Do I want to split this out? What kind of architecture do I really want out of this? That's not really one of the core principles of TDD, other than the refactoring thing is kind of how Kentex says. That's where you just kind of do all this sort of stuff. I prefer to think about that just a little bit up front and make sure that I am, rather than taking up a series of blind turns in an alley, I'm actually stopping every so often to look at my map and think, what responsibilities are along my classes, how do I make them, you know, cohesive, how do I make them loosely coupled, and follow those sorts of principles and end up with good code. So TDD is definitely not the only principle to follow. You only have to follow and write good code. There are other things that are required in order to write good code. But as you're seeing here, TDD is simple and easy to do in JavaScript. It's not a scary thing. It takes 2 minutes to get set up and start running. And to integrate with your CI, that takes a little bit more work, but it is possible to integrate with your CI as well. I think every major CI system out there will run JavaScript tests. So please start testing your JavaScript, and please start test driving that. Thanks very much for the presentation. If anybody has questions.